Dr. R. Sugaraj Samuel. He is working as a professor in physics at New College, Chennai. He is also training students for IIT JEE, AIEEE and BIT SAT. He has more than 16 years experience in both teaching and research. He has published a book titled The Complete Handbook of Bachelor of Electronic Science Practicals, which is prescribed for the syllabus for BSc Electronic Science by University of Madras. He has presented papers in several national and international conferences and has also conducted many training programs and workshops to motivate energetic students. His research areas are ultrasonic, polymers, crystal growth and photovoltaic systems. He is experienced in both regular classroom teaching and online teaching as well.
Welcome to UGC lecture series on oscillations and waves. We have been listening to a series of lectures on the topic oscillations and waves. In this lecture, we are going to move on to the second module of this lecture series. That is, we are moving ahead to learn about the concepts related to waves from this lecture. Before we start the lecture, let us see the session outline for today's lecture. This is going to be the session outline. In this lecture, we are going to learn about the wave motion in particular, followed by the concepts related to plane and spherical waves, longitudinal and transverse waves, and finally the plane progressive wave or travelling waves. Before we go ahead in learning about the waves, we should understand what is a wave, how it is different from the so called oscillations we have been discussing about so far. We have thoroughly understood what is oscillation, the related concepts, the energy related in a oscillation and damped oscillation, forced oscillation, coupled oscillation, all that, simple harmonic oscillation, all this we have learnt, and this is going to be the prerequisite for understanding the concepts related to waves. So, we should know what is a wave and how it is different from oscillation. So, let us see the basic definition for a wave first. What is a wave? And this gives us some easy definitions for understanding the wave motion. In simple term, the propagation of disturbances in a medium is called wave. It is just the disturbance that is travelling in a medium. What is meant by disturbance? We need to learn much more about that. That is what we are going to learn in this lecture. And let us see the other definitions also. Deviations from a state of rest or equilibrium from place to place in a regular and organized way is called waves. Again, it is refined definition. The disturbance that is caused organized way, regular and organized manner that is happening in a medium is also called wave. In nearly all areas of science, in real life, energy is transferred via the vibrations that make up waves. So, we have seen the definition in bits and pieces. The basic definition says it is a disturbance that is travelling in a medium. The further definitions give us the clarity about what is disturbance. It is a deviation. The disturbance is nothing but the deviation from the mean position, and that indeed is propagated or transferred in a regular and in a periodic manner ahead in a medium, and the energy is transferred in this process. So, these are the different perspectives of understanding a wave. We need to learn much more about the wave, but with this preliminary concepts we are starting this lecture and we have to build a lot on this. When we say disturbance, it is simply the oscillation. From the mean position something is varying with respect to the mean position. So, that is the basic definition for oscillation that we have learnt long back. But in the case of wave, that disturbance is moving ahead, that is propagating in a medium. There are waves which does not require a medium also. So, that also we need to learn, but in space or in medium, if the disturbance propagates, if it moves ahead, then it is called a wave. Let us see further what is that disturbance and what it is and how the disturbance could propagate. So, there are some technical terms according to our defined curriculum. We need to be familiar with some of the technical terms. So, let us see the technical terms one by one, and thus we will be able to get greater understanding about the concepts of waves. The example for wave motion are these: waves on strings, the tightened strings on which waves are propagating; water waves, they travel on the surface of water; and seismic waves, the vibration that is happening in earth either inside or on the surface, that is called seismic wave. Then of course, the very famous sound wave, and all electromagnetic radiations including light, X-ray, etc. all these are examples for waves. We have just given some examples in random, but they can be classified. The waves can be classified, the manner in which it propagates, the way in which the oscillations occur, the direction in which the oscillation is occurring when a wave is propagating. Based on some of these criterion, we can classify the waves. So, we are going to see some of the classifications for the waves, and when we give the definitions for the classification, we indeed learn more about the concepts of waves. So, let us see what are these classifications. We can classify wave motion into several different categories as spherical and plane waves, longitudinal and transverse waves, mechanical and electromagnetic waves, standing and progressing waves. So, these are some of the classifications that we can have as far as the wave motion is concerned. Let us see what is the classification done so that we call it as spherical and plane wave. Let us see what it is. See, in a spherical wave, the wave starts from a particular point and it is propagating in all direction, and here we have taken an xy plane, and from the center point the wave is emanating and it is spreading through the entire space in a two-dimensional space. So, this is a spherical wave, it is propagating. Just for the sake of giving the example, it is given in a two-dimensional form. It could be extended for a three-dimensional space also. The wave could emanate or it can propagate into x, y and z direction. In all three direction also the wave could propagate. So, what is a spherical wave? It starts from a single point and propagates in all direction, and that disturbance is moving outwards from a center point. So, that is a spherical wave. Then what is a plane wave? Plane progressing wave. So, let us see the animation for a plane progressing wave, and then we will compare these two waves. So, this is the example for a plane progressing wave. So, in this case it is not starting from a central point, it is moving in only one direction. Maybe in this animation it is shown as if it is progressing in the x direction, it is traveling in the x direction, and it is starting as a plane. In the y axis the plane is existing, or YZ plane we can take, and it is moving ahead in the x direction, it is a plane wave. Now, let us compare these two waves, the spherical wave and a plane wave, and see the similarities and differences between the two. See, this is another illustration to show the spherical and plane wave. But when we carefully look at this illustration, see, this is starting as a spherical wave because there is a central point, it is propagating, a part of that is only shown here. So, the wave front, this is called the wave front, and it is propagating like this and it is moving ahead. And when we have a very long distance of travel, at one point when we take a small part, this spherical wave front itself would appear as a plane wave. So, the spherical wave and plane wave, they do not have much difference when the point of observation is far away from the starting point. So, a part of the spherical wave front will become a plane wave front after a long distance of travel. So, this is also showing the same, maybe with the direction of propagation. Here it is emanating in all direction, plane wave is traveling in only in one direction. Now, this is the comparison between the spherical wave and plane wave. The spherical wave propagates in all direction, plane wave propagates in only one direction. Spherical wave originates from a point source at a finite distance, and in the case of plane wave, it originates from a point source at infinite distance. A spherical wave has a wave front which has a finite radius of curvature, and in the case of plane wave front, the wave front has infinite radius of curvature. So, these are some of the points that we could compare, but when the spherical wave, when it is propagating, when this wave is propagating to a very long distance, this curvature initially it is more curved, but as it propagates, when we observe a small point of that, after traveling a long distance, the curvature is made erect and there is no curvature, the radius of curvature becomes infinity and it is propagating to a very long distance. The curved wave becomes a plane wave after a long distance of travel. So, that is what we should keep in mind as far as the plane wave and the spherical wave are concerned. Now, let us go ahead to learn about what is the other classification we can have. This is based on the wave front, spherical wave and plane wave, but based on the direction of vibration that is propagating, also we can classify the wave. And how it is done? Let us see the concepts further. On the basis of the direction of vibration, the waves could be classified as longitudinal wave and transverse wave. First, let us see the definition for longitudinal wave. If the local displacements of the medium are in the direction of travel which is parallel to that of the disturbance, then the wave is called as longitudinal wave. The example for such wave is sound wave through air or compression waves through some solid objects, and here it is illustrated. The wave is propagating in the x direction and it is marked here with this arrow mark, and the vibration is also in the same direction. It is also happening in the x direction, maybe x and minus x, it is not the y and z, it is only x and minus x. In that direction the vibration is happening, the wave is also propagating in the same direction. In that case, the wave is said to be the longitudinal wave. And what is the other one? It is called the transverse wave. So, in transverse wave, if the local displacements of the medium are perpendicular to the direction of travel, then the wave is a transverse wave. See, here it is moving up and down, the hand is moved up and down, the wave is propagating in the x direction, but the vibration, the displacement is in the y direction. So, when it is perpendicular to each other, the direction of propagation is x, the direction of displacement is y. So, in that case the wave is called as transverse wave. What is the example for transverse wave? That is also shown in the slide. The waves on strings, surface waves on water, etc. are example for transverse wave. So, in general, based on the direction of propagation and the direction of displacement, here the displacement means it is the direction of vibration, we can classify the waves into longitudinal and transverse wave. Longitudinal wave, the direction of propagation and the direction of vibration will be in the same direction, and in the case of transverse wave, the direction of propagation and direction of vibration are perpendicular to each other. We have these two types of waves. When we learn about the equations for waves, each wave, transverse and longitudinal wave, could be represented with different equations. At that time we will get more clarity about it. We will compare this longitudinal and transverse wave. See, these are also some of the animations shown. The first one shows the example longitudinal wave propagation, and the second one shows the transverse wave propagation. See here, the compressions and rarefactions are happening in the case of longitudinal wave, where the wave is getting compressed, it is compression, where it is getting rarefied, it is called rarefaction. And in the case of the transverse wave, it is crust and trough, where the displacement goes up, it is crust, and it is trough when it comes to the lowermost level. And see, this is a static picture which shows in the case of longitudinal wave, it is compression and rarefaction, the direction of propagation might be to the right, and in this case transverse wave, it is the crust and trough. Crust is the highest point and trough is the lowest point from the mean position, and the maximum displacement is amplitude. So, these are some of the terminologies we should keep in mind. In the case of longitudinal wave, we have compressions and rarefactions. Compression, where the particles or the medium is compressed, the particles are very close. Rarefaction, they are far away. And in the case of transverse wave, it is going ahead, the wave is moving ahead as crust and trough. Crust is the uppermost displacement, trough is the lowermost displacement. This is the comparison, I suppose, for the longitudinal and transverse wave, and the important points we have highlighted are all shown here. First two points are the same thing which we have learnt now, and the third point is the longitudinal wave cannot be polarized and transverse wave can be polarized. What is polarization? It is restricting the vibration to one single plane or one single direction, that is called polarization. We will learn about the concept of polarization in the future lectures, how a wave can be polarized, what is meant by polarization, all this we will learn. So, at this point of time, just for the sake of the difference between longitudinal and transverse wave, this point could be taken up as such. Longitudinal wave cannot be polarized, transverse wave can be polarized, and this is a similarity in the case of longitudinal and transverse wave. See, the energy and momentum are transferred and not the particles, and transverse is also the same, energy and momentum are transferred and not the particles. But when we say energy and momentum, how that is transferred in a wave, that is what we are going to learn further. How energy is propagated, how it is transferred in the direction of propagation, in what form, all this we are going to understand in this lecture, because this gives the basic understanding of wave. And what further we have, what further classification? See, this is again a comparison between the term oscillation and wave. We have learnt thoroughly about oscillation and the terms related to the concepts of oscillation, and for the concept of wave, what are the terms related? I would like to go by each term. In the case of oscillation, there is displacement from the mean position, a particle could go up and down or sidewise from the mean position. So, in the wave also the particle will be moving either up and down or sidewise in the direction of propagation or perpendicular to the direction of propagation. So, there is displacement in both oscillation and wave. There is amplitude in the case of oscillation as well as wave. The maximum displacement is called oscillation. There is frequency in both oscillation and wave. What is frequency? The number of vibrations or number of oscillations per second is frequency that is present in both the cases. Time period, the time taken for one vibration or one oscillation is there for both oscillation and wave. And phase, the angular position that is represented as phase, that is also there for oscillation and wave, and this one particular term wavelength is applicable only for wave and it is not present for oscillation, because the wave is the one which is propagating. The wavelength is something related to the wave alone, a progressing wave, and that is not present in the case of oscillation. So, this makes our learning objective very easy. See, lot of terms we have come across. What are common for both oscillation and wave? There are some terms common. There is only one term which is not present in the case of oscillation, that is present only for wave, it is the wavelength. Then what is wavelength? That we have to define. What is wavelength? Let us see the definition for wavelength. The wavelength of a wave is defined as the distance between successive crest or trough of a wave for a transverse wave, and the wavelength is the distance between successive compression and rarefaction for a longitudinal wave, and in general it is the distance between two successive points which are in the same state or same phase of vibration. So, that is what is called wavelength, because wave is the one which is propagating ahead in a medium. The wavelength is to be defined. If we have a look at the visuals related to wavelength, we will be able to get more understanding of what we have seen as the definition. So, let us see the visuals showing about the wavelength of a wave. This shows the distance between two successive crust, and the next picture is also showing, and here it is showing the distance between two successive points which are in phase, and here also it is shown in the same way, distance between two troughs also is the wavelength, and here it shows the compressions and rarefactions. The distance between two successive compression is also wavelength in the case of a longitudinal wave. The wavelength is the only term which comes in addition to the terms we have seen for the oscillation. Now, what is actually going ahead? What is getting propagated in a wave? So, we need to have a thorough understanding of that. We have seen the wave emanating from a point called as spherical wave, the wave propagating in a single direction called plane wave. How a spherical wave becomes a plane wave after travelling a long distance, that also we have learnt. The transverse wave propagates in the form of crust and trough, longitudinal wave travels in the form of compressions and rarefactions. For the transverse wave, the direction of propagation and the direction of vibration are perpendicular. For longitudinal wave, the direction of propagation and direction of vibration are in the same, all these we have learnt, but actually what is propagating, what is moving ahead, that we need to understand. That makes the learning easy when we know what is actually propagating in space. It is not the particle that is travelling. A particle which is vibrating does not move in the direction of propagation, the particle should remain there itself, but the disturbance only should travel. So, there are some illustrations that we can have a look at it to have a greater understanding of what is actually propagating in a wave. A plane progressive wave. A wave which travels continuously in a medium in the same direction without any change in its amplitude is called plane progressive or a travelling wave. A progressive wave may be transverse or longitudinal in nature. So, the wave is the one which has to continuously travel without any change in the amplitude, but practical sense there will be a decrease in the amplitude due to damping present in the medium, all that we need to learn at a later stage, but at present the ideal wave is the one which always propagates. It gets energy and that energy is transferred ahead and ahead and ahead from one particle to the other particle, and it is going in, that process is going on and on as far as a progressive wave is concerned. This is a typical example for the wave propagation. It is called as Mexican wave. It is normally done in the big stadium and auditorium. See, here you can take each person moving up and down, could be representing a particle moving up and down, but the person is there, he is not moving ahead, but the disturbance is moving up and down, that up and down motion is going ahead. It is passed on from one person to another person and another person and so on in a systematic way. There is a sequential method in which it is happening. So, this gives us an understanding that the particles are not travelling, the disturbance is only travelling in space. This is also another illustration that gives us some understanding. See, the people moving their hands up and down, they raise and sit, that is it, and that is indeed transferred to the next person, next person, next person and so on, and this has a wave motion. They look at their hands or the hip, it is going up and down, but the wave is propagating perpendicular. So, it is a typical example for the transverse wave. So, the energy here, there is kinetic energy, the moving up and down has a kinetic energy, that kinetic energy is transferred to the next person and his kinetic energy is transferred to the next person and so on and on and on, and it is happening forever as far as a plane progressing wave is concerned. So, this is how the wave, the energy is transferred from one particle to another particle, from one molecule to another molecule, from one atom to another atom, like that, because they are all joined together in a medium by some sort of force. So, by which it is propagating. What is the role of the force that is connecting the two vibrating particle? That we will be learning more in the coming lectures. And this is also one concept we should understand. In progressing wave, energy, the kinetic energy and momentum are transferred from one vibrating particle to the other. If energy is not continuously supplied, the wave will damp or it will die after travelling some distance. So, this also is represented here, the wave damps after travelling some distance. And there are some waves called Rayleigh waves, they have a rotatory motion. So, this is also possible, it is neither longitudinal nor transverse, and it is called surface wave, that is happening in some liquid surfaces and all that. So, this is also one example, one kind of wave. This we will not learn much in this curriculum. Then we have a concept called electromagnetic wave. In electromagnetic waves, the electric field and magnetic field are varying perpendicular to each other and perpendicular to the direction of travel. Electric field, magnetic field and direction of propagation are mutually perpendicular to each other. Electromagnetic waves do not need a medium for propagation, they can travel through even vacuum. About this also we will not learn much in the lectures, this is reserved for a higher learning, and this is how the electromagnetic wave will exist. The red color shows the electric field and the blue color shows the magnetic field, they are perpendicular to each other and it could travel in even vacuum. Before we wind up this lecture, we will summarize what we have learnt in this lecture. In this session, we have seen the concepts of wave motion, plane and spherical waves, longitudinal and transverse waves, mechanical and electromagnetic waves, and finally plane progressive or travelling waves. Let us test our understanding by answering these questions. What is a wave? How it is different from an oscillation? What are spherical and plane waves? Differentiate between longitudinal and transverse waves. Define the term wavelength. What is a plane progressive wave? So, with this I would like to wind up this lecture. Hope you have understood the basic concepts of waves. We will see further the concepts in the upcoming lectures. Thank you for watching.